We're now going to look at problem 7-67, and this problem looks at how much of each product, so what should your product mix be? Because companies rarely, of course, sell one product, so they need to know what combination is going to give them the best return. So the first thing we're going to do with this coffee company is calculate your contribution margin. So all of this information, the data is given in the problem. We have small and large size coffee, and the information is given in the problem. The selling price, $2 for the small, $4 for the large, the variable expenses for each, and the contribution margin. So what we're also told is that the current sales mix is that they sell, for every 1 cup of large coffee, they sell 3 cups of small coffee. So we're looking at the contribution margin per unit, and our total is $5. So we're looking at combined $5. And in this case, what we're doing here is we're looking at the weighted average. So what's your contribution margin generated from both products on a combined basis? So it's your $5 divided by the 4 units, the 4 cups of coffee, would give you a contribution of $1.25. So now that you have your weighted average, what you're trying to do now is figure out the number of units to break even. So here you have your fixed costs, which you're given that data in the problem, 20,000. 0 is here because what that specifies is that you want 0 operating income because you're looking at breaking even. So with 20,000 in fixed costs and no profit at all, and divided by your contribution margin per unit, so 20,000 divided by $1.25 will give you 16,000 units. So that's 16,000 cups of coffee. So now what we want to look at is, what is the mix? How many large versus how many small? So we see that from the problem we're told for every 1 of large we sell 3 of small. So 3 divided by 4 times 16,000, it's 12,000 cups of the small coffee, and 16 divided by 4 is 4,000 cups of the large coffee. So that's the breakdown in terms of the number of cups of each size coffee. That's just to break even without making any profit. So if you want to look at this another way, in terms of just like proving it, if you sold 12,000 cups at $2 and then 4,000 cups at $4, 40,000, we have our variable expenses of 20, give you a contribution margin of 20, your fixed costs are 20, so you end up with 0, which is break even. So that proves that at that sales level you will end up just breaking even when you're selling 12,000 units of small and 4,000 units of large. Now there is one point to note here, and you've seen now a couple of break-even calculations, and one thing to be aware of is when you're calculating, if you're looking for break-even, and I use abbreviation, so break-even sales in terms of units, you will have your fixed cost, and that will be divided by the contribution margin in dollars. So, and that was the case in this problem. So if you're trying to figure out how many units you need to sell to break even, it's your fixed cost divided by your contribution margin per unit expressed in terms of dollars. If you're looking for break-even sales in dollars, then you're going to have your fixed cost divided by your contribution margin percentage. So it's going to be expressed in terms of a percentage. So just a little point to keep in mind. So So the next thing that we're asked to do here for this problem is compute the margin of safety. And they want the margin of safety in dollars. So when we're looking at margin of safety, what that is our actual sales less break even. So how much are we selling above the minimum we need to break even? So our actual sales, and we're given in the problem that is $90,000, and we've just calculated the break-even sales is going to be $40,000, and we already did that in requirement 1. So our margin of safety is $50,000. So that's a very healthy margin of safety. So if you were in a situation where your actual sales were, say, maybe $45,000, then you'd only have a $5,000 margin of safety. And that is somewhat risky when you have a very small margin of safety. Obviously you're not making a lot of money, but it also puts you at risk for taking a loss, because you don't need to have much of a change in terms of loss of sales or maybe an unexpected increase in variable cost. All of a sudden you have no margin of safety and you're not even breaking even. So it's always important to look at your margin of safety and have a good healthy spread between the actual sales and break even. There's no an exact amount or percentage. It's whatever the company feels is appropriate, but if these two are very close, then you don't have much of a margin of safety. So the next item we're asked to look at here under requirement 3 is to look at the operating leverage factor to see what impact an increase in sales volume is going to have. So when we're looking at operating leverage, the formula for that, and this is just a formula you're going to have to memorize, and in the exams formulas are not given, so you are expected to know these formulas. So contribution, the operating leverage is your contribution margin divided by your operating income. So when we are taking this information, the contribution margin, $45,000, that's taken from your statement, income statement at the top of page 446. That's where the 45 is coming from. And similarly, the $25,000 is also taken from that table. So that's for the operating income. So your operating leverage is 1.8. So what this means is for every 1% increase, you will have a 1.8 the operating leverage. So 1% increase in your volume is going to be reflected as 1.8 times that in operating income. So you see what happens here is if the company had a 15% increase in volume, so you have 15% times 1.8, that is going to lead to a 27% increase in operating income. So that's what operating leverage factor means. So the higher this factor, it means whenever you sell more, you're going to generate a significant increase in your operating income. So now that we know that if we increase our volume by 15%, with operating leverage of 1.8, that's going to lead to a 27% increase in operating income. So that's pretty impressive. So you take your old operating income of $25,000, which is in the table in the book, increase that by 27%. That's going to give you a new operating income of $31,750. So that's pretty significant. And this is a very quick calculation to use. So if you are doing sensitivity analysis, which is where you look at various sales levels, if you're saying, well, what about if we increased our sales by X, what would that give us on our bottom line? So by using this formula, rather than going through and calculating a whole new income statement, you can very quickly see what the impact is going to be on your operating income without having to prepare a full income statement. So that concludes requirement 3 and of this problem, and we will there is one more thing. Before we conclude, if you just want to sort of prove this, you can see here that it does in fact work. So you see, if you increase your sales by 15%, your variable expenses are going to go up by the same amount. That's going to give you an increase in your contribution margin, $67.50. Add that to the $25,000 you already have, $31,750. So that shows that that calculation does in fact work. Okay, so now that does conclude problem 7-67.